So now moving on to CMIP7 and what you can expect from that. So just a bit of background on CMIP. It's started as a very research-focused endeavour in the mid-90s, but it's now grown hugely. Its standardised climate output is driven both climate model development, climate science, and increasingly used by policy assessments, both nationally and internationally, most notably the IPCC. CMIP6, which was the last phase, was the biggest yet, and there was a huge increase in the number of countries and models that were involved and the number of experiments run, and then a huge increase in the amount of data that's available, which continues to grow. But also recently, and in recent years, there's been an increasingly wide and diverse range of users, such as yourself. So we're now looking to how we can engage across this full climate information chain. So what will CMIP7 look like? This graphic kind of gives our conceptual vision as such. So we have all of the community model intercomparison projects that will happen with all those important experiments addressing key scientific questions in every aspect of the climate system. But to help sort of reduce the burden on the modelling centres, we've pulled out this subset of experiments that are particularly critical for science and scientific and policy assessments, and particularly on the timeline of the IPCC Assessment Report 7. So that is being called the CMIP7 Assessment Fast Track. It includes historical and scenario experiments, which are generally the most used. And it's going to also be used as sort of input for those further down the climate information chain. For example, in regional downscaling, Erasmo will tell us about CORDEX shortly. For modelling climate impacts in the impacts CMIP, and also things like ice sheet changes, which is vital for sea level. So I'm just going to cover some of the new aspects for CMIP7. Emissions-driven scenarios and simulations will be a key feature. So that will mean that many of the models will run in what's called emissions-driven mode, and that means the model itself simulates the carbon cycle, and you have that carbon cycle feedback, and also then alters the resulting levels of CO2 in the atmosphere. That gives a much more realistic representation of the carbon cycle and how it might change under the different levels of warming. It aligns better with the climate policies that are typically defined in terms of emissions rather than atmospheric concentrations. So the idea on this graphic on the left here, you can see is for CMIP7 that there'll be a closed carbon cycle in many models. And then looking beyond CMIP7, we would hope to also close those nitrogen and methane cycles. Another update will be in the historical forcing data sets. So these are the standardized input data sets that drive the CMIP historical simulation. These have now been updated to at least the end of 2021. And there's an ambition to provide annual extensions of that to increase it to nearer real time. We do have one new data set for CMIP7, which is population density. That is because that's required by some of the models which now have interactive fire. But this sort of core set of forcing data sets covers the key natural and anthropogenic forcing drivers. Also, we have a new set of scenarios. Probably you have all seen them in the media recently. So these are the emissions pathways, and they've been revised from CMIP6 to reflect where we are now, and also we've moved on too quickly, where the energy and various other integrated assessment model outputs are looking at where we will go in the future. They've been renamed to try and be more descriptive of the emissions pathways they are taking to make it easier for communication. Here are some of the key points that have come up in a lot of this media interest and also questions that have come in. The high scenario has been the one that's attracted all the attention, that's seen as being lower than the previous ones, and it does result in lower emissions at 2100. That is mainly driven by the fact that since the last scenarios, we've moved on 10 years and we're also have followed a sort of middle of the road pathway. So that means that the rate of change, even if it stayed the same, would be in a lower point at 2100. There's also been considerable advances in renewable energy and falls in the costs, and that has implications on the emissions. But if we look at the warming estimate for 2100, it's still around 3.5, so that's still at a very high level. And it continues to rise after 2100 in that high scenario. The lowest scenario, even at there, overshoots the 1.5 degrees Celsius by 0.2 or 0.3 degrees at least before returning back to 1.5. And that really requires a lot of carbon dioxide removal that's both technology and nature-based. What we've got for the scenarios for CMIP7 is these temperature overshoot scenarios. So as you've seen, we need to investigate how these reversing warming trends by removing carbon will impact, I think there must be a timer on society and ecosystems. Another activity that was really a community-driven aspect of the development for CMIP7 was what's called the data request. So that's how all the variables that are requested from the modelling centres to output. This time we had a dedicated impacts and adaptation team. So Andrew was part of that, and they helped with representatives from across different sectors develop the request and identify those variables that are really key for that impacts and adaptation modelling. So these are just some of the examples. We have a baseline climate variables that gives those sort of small number of very highly used variables that we want every modelling centre to output. But then there's aspects like vulnerability of urban systems, infrastructure and population. And we've got some new variables, things like hourly relative humidity, which is obviously vital for things like heat stress alerts and those kind of modelling. Just a note that they are just a request and the modelling centres decide what variables they produce. CMIP is very much a sort of community effort, so there's no strict guidance on that they have to do what we tell them to do as such. Another aspect that could be useful for the users of CMIP7 is the essential model documentation. Previously, there was quite inconsistent information on all of the different models that were coming out of CMIP, and some of you have likely experienced that. So the aim is to have a sort of small set of information that is required for the modelling centres to publish their model data, and that will mean that all of the models will have this essential model documentation, so information on the grids, on the components and aspects like that. So it's a bit more of a reliable point for users. So importantly, where can you access the CMIP7 data? Oh, I think there should be a QR code here. We'll add that after. So it's going to be on the ESGF as previous generations have been. There is not any data there from CMIP7 quite yet. We are expecting it within July. There's a number of centres who are almost there. They're preparing their data. But it's good to note that despite the best efforts, there's always errors. So we do have a new errata service as well that you can find at that link there. And also we've been developing full kind of user guidance on our GitHub pages. So these links can provide that. Also note it's we've now got a data disclaimer, so it's useful if you can read that when you're using the data. We'll update with the access points and distribute that following this. Another kind of area of strategic development that CMIP is working into is a sustained mode. Because it's a research activity, but it's relied on in a sort of operational sense almost. We're looking that we need to have this sustained mode that is delivering at set times and with user needs in mind, not operational in the sense of weather prediction, but that is reliable for the users that are needing it. So that would mean that there's sort of regular, timely updating, but also that we need to find sustained funding for all of the key dependent components of it. And we'll hopefully have those annual historical forcing data sets being updated annually. There's kind of two elements of the research focus. There's a research focused infrastructure that would be similar to the SGF as it currently is, but there also needs to be an infrastructure that's potentially more user friendly, more equitable and accessible, you know, utilizing the new data technologies. So we do need to look at long-term sustainability. CMIP and CORDEX are currently supported by a global collaboration of national and regional research funding, things like Horizon funding put in quite a bit, but all of those national fundings for the modelling centres, for the infrastructure, and the in-kind contributions of all the scientists that take part. But with these kind of higher expectations from users, we've got increased model complexity and resolution, and geopolitics, which is increasingly volatile. We're really facing a big challenge. So a question to think about that will come back later in the discussion is, what would you do without CMIP and CORDEX data? And I'll hand over now to Erasmo to give you an update on what we can expect from CORDEX.
Good morning, everyone. Thanks for the invitation to present CORDEX, which I'm sure has been appreciated by the whole CORDEX community since they sent me here. My name is Erasmo Buonomo. I work at the Met Office and I've been working on regional climate modeling for the last 25 years, probably. And so I'm here to present the work of CORDEX, which is now has been for some years under the World Climate Research Program. The main purpose of CORDEX is to work on downscaling global projection. By downscaling means the target resolution now is 12 kilometers for the physical modeling, but CORDEX also includes statistical downscaling, which gives point values. And the CORDEX goals are not just to produce a set of coordinated experiments, which is point 3 in the goals, but also to understand local processes at regional level, which are very difficult to assess from global climate model, and also to improve this description of the downscaling process and the results of our model. We are also having a regular communication exchange with all the community who are interested in using our data. This might be an example, but we have also conferences, and we organize workshops for people who want to use that, in particular in developing countries. The part of the simulation is organized as described in these slides. Mainly the land part of the world are divided into 14 regions. There are some overlaps. For each of these regions, we try to use the same experimental protocol, the same setup for the model and the same way of running, which is basically the basic assumption is to use the seasonal wet temperature from the GCM or for the analysis when we are doing evaluation run. CSST and sea ice as well, and then to use regular update of the atmospheric boundary condition at least every 6 hours. That is in common with all the models, with all simulation, but also there are other aspects that are described in this protocol. The other thing that makes the project worthwhile is to have this common output also distributed on the ESGF nodes, which allows a kind of work comparison and impact studies. With this domain, we have communities organized around them, usual people, scientists working in the region, but also there is some interest from other countries to participate in other domains. In our case, for instance, mostly from development funds. And as just mentioned by Eleanor, this is not directly funded. Most of the funding comes from national climate scenario work in basically all the Western countries and some other fundings from European projects, for instance. And from the last iteration of completed simulation, which was driven by CMIP5, I would like to present two examples of the additional activity on top of the simulation, just running and distributing the simulation. Here, for instance, we got an example over Europe, where it has been found that the 12-kilometer simulation give a different climate change result with respect to the driving GCM. Now, this implicitly was an inconsistency, but when the scientists who worked on this problem went to find out what was happening, they found out that it was merely due to the fact that with the higher resolution, we have higher elevation for the orography, so the Alps are higher, and that created a lot of convective activity that justify in full the change of the signal, and this is very important because this is still a populated region. In terms instead of an example of evaluation, we also presented, document what is wrong with our simulation. And this is again the case from Europe, from the CMIP5 simulation. We found out that there was a rather big discrepancy in particular. This is the point. In Central and Southern Europe, in the climate change signal between the driving GCM and the regional model, it was up to 2 degrees. That is something that we are not expecting. It's not supposed to be like that. We are expecting consistency at this level. There were a study conducted by a French team, and they found out that it was mainly attributed to the effect of aerosols. So this is something that we take forward and try to improve the protocol of the simulation. The analysis of the present run are not just the basic science, are also planning strategic activity for the future. Part of these are into the CORDEX task team. So we have a team, which is actually working on a strategy for regional couple model with the ocean, because right now we just use the atmosphere and the on the surface. The ocean, as I mentioned earlier, is prescribed. And this is important. Like, for instance, if I give an example, risk-related example, tropical storms are heavily affected by interaction with, between the ocean and the atmosphere. So you don't have the process yet, but it will appear in the future. Convection permitting model is the new tool that we have. Basically allows us to increase the resolution up to, or the range of few kilometers, 1 or 2 kilometers. This resolves many of the problems that we had in representing some process. The main one is daily the diurnal cycle of daily precipitation in the tropics, for instance. But there are many other things, in addition to the fact that we have higher resolution data sets for impacts. There is also, actually, from my point of view, one of the best application of machine learning in the world of climate, which is this attempt to create emulators for RCM. So basically, we want to avoid the RCM downscaling altogether and use emulator rather than the expensive models. And for that, we have the best training data set because we have downscale simulation for the present and for the future. Therefore, we're not expecting that the machine learning algorithm will have to go out of sample. The work is ongoing. They finally have decided a benchmarking data set in different regions of the world for which they have very good data set. They will try to emulate, and this basically a beauty context of the machine learning methodologies. And I'm going to talk about the 2 other bullet points later. What is missing here is the regional Earth system modeling, following what the description of CMIP7. I will have to do something there as well, because we cannot go the usual way of running our models. Another way to get in depth and to increase the value of the work within CORDEX, the coordination within CORDEX, are the so-called flagship pilot study, which focus on particular region or subcontinental scale or on particular processes. At the current stage, there are active projects, in particular over small islands, because that was the last call for which convection permitting model is used, but still within the CORDEX frameworks. Another one which is important is the ongoing studies on the so-called third pole of the Himalayan plateau, because it is another region which is very difficult to model. But among the projects that have been going on for a long time, there is the urban climate. If you are interested in the urban heat island effect, that is the flagship study that has been working on that and then raised the issue of including proper urban component in our model. among the completed ones, there is one on the effect of land use on climate change. And that was based on a very good historical database over Europe. That database has been expanded all over the world, so we are expecting to use this in the future simulations. What is new is the CORDEX score, ongoing CORDEX score are the simulation run by CMIP7. All the domains are doing something. The current planning, there are like commitment for 900 simulation. The experimental protocol has been refined, as I mentioned earlier, taking into account what we found in the previous iterations. What is changed? One of the main changes here is that we try to have a more coordinated approach to the selection of GCM. The point is that I mentioned that we have tens of GCM giving us boundary conditions. I think there were 30 at the last iteration. We cannot run all of them, so we have to select some of them which are suitable for the task with two criteria. They have to give a decent baseline, and that is mostly defined in terms of local circulation over the continent, and they have to capture the range of output from the future. So the spread in climate change given by the driving GCM. There's been a revision of the output list, but I will talk about this later. And these slides, particularly the lower one, report the activity. Sorry. Yes, the activity by domain. And you can see that there are 4 domains which are very active. 3 will not be surprising. Probably Southeast Asia is not surprising, but they're very committed to this kind of work, and they have structure and model to do this. And that creates the problem. What do we do with the other domains? That it is, from my point of view, the main motivation of CORDEX score. So there is another experiment in parallel to CORDEX, another activity which is actually regulated by a task team, which we in a sense, those who can afford, try to model all the regions, actually not all the regions, just 9 regions of the world, but sufficient to cover all the land, almost all the land, and basically all the places where people actually live. The previous iteration of CORDEX score at 25 kilometers has been, very successful because it was the main thing picked up by the IPCC report. We are trying this new iteration with the target resolution of 12 kilometers. Again, we follow the same principle on the selection of the models, just 3 models. We can afford just 3 models. There are 4 RCM groups involved. And the scenario is the SSP 3.7, so not the highest one, but the highest reasonable one. We also we are planning activity to use CMIP7 straight away as they come from the fast track data set. But I'm not talking too much about that. This is my last slide. It is the main outcome from the simulation is this output list. We are now divided into 3 levels. There's the CORDEX score output that will be available from all the simulation everywhere because it is compulsory. Tier 1 is a lot of variables, 150. There are basically all the variables that are allowed to do very detailed impact study, for instance. And most of the team will distribute this, but probably not at the first iteration. And then there are some more exotic variables in tier 2. Some of that are not are ill-defined. We have tried also, like mentioned by Eleanor, we have tried to include as much as possible from the requirement of the impact community, like we have like 50-meter wind speed for renewables or direct sunlight, which I only use for building, energy consumption of buildings, or variables like that. And the final bit is that now with the ESGF coming back, we'll be required to finally put all the data set in black in the previous slide. Well, just one thing. The thing that is missing here, and it was in the CMIP7, is that we, as far as I'm aware, we only produce one set of guidelines of how to use this massive data set for EuroCortex. There is a specific WCRB group that's called Regional Framework for, yes, which will work on the so-called problem of the distillation, how to put together all these different data sets, but we will revisit these guidelines because we have something to say on the topic. Thank you.